very brief introduction. Hi, everyone. Welcome to the Boston Closure Group meetup. Our topic today is advanced topics in Saite for dashboards and data exploration with our longtime Closure friend, John Anthony. So this is the second of a two-part series. So if you saw that, welcome back. And if not, I think you can pick that up. And of course, you can go back and see that recording and check out anything you missed. So without further ado, here's John Anthony.
Hi, my name is John Anthony. Just a short intro here. I'm a computational biologist at a couple of labs in the biology department at Boston College, and also kind of a general software person for them. I've been with Saite kind of sort of from the beginning, and this is mostly in that vein with data analysis, visualization. And in this case, Saite is sort of a kind of akin to an RStudio kind of exploratory, dynamic kind of environment. And today, as Mark said, we're going to do a second part of Saite where we're going to do the more advanced kind of features and stuff and look at it and hopefully build a small, trivial dashboard, but we'll do the whole thing from kind of soup to nuts. And that, let's see if I can share my screen here, and we'll be off. Okay, can people see that?
Yep.
All right. All right, so what we're going to do is talk a bit about reactive components, then the callback functions and their necessary databases. That's a little bit of a different thing. This business of mixed code techniques, and we'll talk about that. Some of this was covered in the previous session, so, but this will be more extensive. We'll be talking more about how this mixed code stuff works, and in particular, how it works and helps with dashboards. And then we'll talk about widgets and how widgets are abstractions of these reactive components and how those abstractions are made. And then very briefly talk about the API. There's not a whole lot to the API to this for doing these sorts of things. And then the live examples is really turned into an actual dashboard example. So off we go. So first thing is reactive components. So Saite is built on reagent, and it comes with Recom enabled. And the real reason how it gets all this stuff is that it's layered on top of Hanami, which is a library for building visualization applications. Hanami itself doesn't really do anything. It's literally more a library than anything else. It's not a tool. So because it's set up on top of reagent, these components are reactive, and they will automatically do DOM updates and things like that when various things happen. So Recom is something, I don't know if people are familiar with it, but Recom is something that I find really nicely done. And I'm going to go over to the site, and this is a kind of the documentation for it, at least at the very high level. It's really nicely done, and you have all kinds of components. This entire page is actually built with Recom, so it's one of those kind of recursive things where it's done inside itself. But you have all the different kinds of buttons you might typically want to use, all these different checkboxes and so, slider things. And we'll actually be using slider and input text and some other, and there's drop-down selections. There's just a myriad of things. And these things are really nicely done in terms of showing the demos and the page source for actually building this page for every component that's on here. Some multi-selections, there's all kinds of stuff here, including tables. All this stuff is directly available. And because of that, also including layouts. So Recom is completely layered on top of the flex box concept in CSS, which makes laying things out and having them behave in ways that are kind of rational really nice. Not being a CSS guru, this has been something of a godsend to me personally. It's just a really nicely done thing that works seamlessly with Reagent because it's built on Reagent, and just provides you an enormous amount of capabilities that I personally probably would have almost no idea how to do from scratch. And the really cool thing is in Saite, all of these things are directly available for you when you're building your dashboard. So you can lay things out and using any and all of these components. All of this kind of stuff could be used. Most of the time, you just use the really simple things like checkboxes, radio buttons, of course, input text, sliders, this kind of stuff here. But lots of other things in this, like the tabs, all right, all that stuff. That's directly used, could be used actually in your dashboards as far as that goes. But all this stuff here, so this presentation is in Saite, and all these this tab stuff here is built with Recom tabs, and all this document body stuff is sort of in there as well. The other really big thing is that you have all these code mirror editing capabilities. So there's lots of code mirror editing inside of Saite, and that was gone over in the first session, so we won't really talk too much about that. All right, so but if we look at this again, I should have probably not close that other window, but it doesn't matter. Let's go like this slider as an example. These components have models, and these models are the things that get updated or react when certain things happen, and they have callback functions. Most of them do. And those are the things that get called when anything in the model changes, and then you can make another change to another model, and all sorts of reactive firings take place and updates happen and all kinds of things happen. So it's pretty neat in that regard. But because of that, we have to sort of describe a bit more about how callbacks work in Saite. So yeah, they're the on-change functions for these reactive components, which are the Recom things. They're called whenever a model changes something or a user does something. So as an example, like these are buttons here. These are actually Recom buttons. This is a code mirror editor that has an example of a Recom component using the slider in this particular case, where it uses radums, or these things, that reagent atoms, typically colloquially called radums. So we can execute that, and we get a change down here in the output buffer, and we can move these things around. If we have larger output, this will fill up and we can do things with it. And, but as we click on this button here, that clears the output buffer. And so that's an example of when I click this, one of these callbacks takes place, and it's passed some various information. And one of the things it does, it knows is what it's supposed to do is clear the output buffer. So that's an example of a callback that's built directly into Saite. These things are closure script functions. I mean, in principle, you could write them as JavaScript functions, but why do that when we can use ClojureScript? And since Saite is fully enabled for self-hosted ClojureScript, we can run all kinds and define all kinds of ClojureScript functions and have them execute in various ways. Also, these functions can utilize this mixed code capability, which we'll talk about next. Then we need, there's some associated databases. Database may be a glorified way of talking about this stuff because they're really just maps that happen to be able to be saved when you save a document, like again, this is that kind of stuff about all these controls and whatnot that was discussed in the previous session. So we're not going to go much into that. But when you save one of these documents, you have to be able to save the images and any associated widgets and things that might be in your dashboard. In order to do that, you can't directly save the functions themselves. And like up here, this on change in the Recom, it needs to be a function. Okay? That's what Recom is expecting, is a function there. And the model, it should be a Reactive, but Reactive is effectively an object, and this function is effectively an object of some sort with a bunch of code in it, compiled code. And those things aren't directly savable. So you need some way to, a simple way to flexibly serialize these things. So the Reactive database is for these component models, and the function symbol database is for the callback functions. And what basically happens is you create a representation in these databases that are directly savable. And when you reload the thing, it reconstructs the stuff so that your widgets and your reactive components and all that get re-enabled. Effectively, you rebuild the function and you rebuild the reagent atom and all that stuff. So you need these things in order to support that. And it's really because of this, we need to, cross between having a live document where you have live code and all that stuff, and then you save it and you maybe close down the server and everything else, and then you start it all back up. You need to be able to then reload things in such a way that it all comes back to life. The other thing is this symbol translation stuff. So what happens is like in this case here, this function actually gets replaced by a symbol that will be automatically looked up in these databases during hiccup processing. And hiccup processing, I'm not going to go into any kind of details on that, but there is an entire description of it over here in Reagent. And Reagent has its own special version of hiccup, but hiccup is basically writing HTML and closure data structures, and it's pretty simple. The most basic thing is all the HTML tags are turned into keywords with special vectors where styling and things are expected as the attributes and that kind of stuff. And then there's some very special versions of this stuff where if you have a vector that's a symbol, then it can also be a ClojureScript function. And that's, in our case, like over here, that's exactly what's going on, because this slider is actually a Recom component. And if we execute that, you'll see that, yeah, it's a function. It's a function. And so when hiccup in Reagent processes this, it knows enough to bet when it finds one of these in a layout, a structured layout, it'll run that function. And most of these functions are, Reagent has a whole hierarchy of these things, kind of, it's a form 1, form 2, and a form 3 component functions. And they all have slightly different characteristics in how they behave and how they're expected to behave. But again, you want to look at that, there's tons and tons of documentation for it on the reagent site and sort of how it all works. We're not going to get into that because it's outside the scope. Anyways, though, the key thing is that we need to be able to register new symbols with this processing, and that's part of what this database does. It's the backing store, if you will, for what Hanami then provides for symbol callback functions. And that's, again, well documented in here about how this works. And when you fire up the server aspect of Hanami, which Saite is layered on, you can pass it this callback function thing, which will, when it finds symbols inside of Hiccup that it doesn't recognize, it'll call this to see if it can figure out what it's supposed to put in there. And that's kind of how that stuff works under the covers. So there we go. And now let's go on to, oh, wait a minute, there's a chat message, I don't know. Oh, okay, yeah, okay, Elena just put that in there about how you can go and browse this stuff. All right, so on to mixed code. So let's move this a bit out of the way here. This is a bit of a review. We talked about this a fair amount in the first session, but we're going to go over this in even more detail this time around. So in code execution in Saite, there's 3 forms. One is code runs on the JavaScript engine and on the client. It's literally just running ClojureScript, or you can execute JavaScript as far as that goes using interop, or you can run it on the JVM server. So it only runs on the JVM server. It's stuff that maybe only the resource is only available for the JVM. There's various libraries that don't work at all in ClojureScript. And often, in particular, if you're running intensive computations, you're going to want to have that on a more capable server where you can spread it across a bunch of cores and all kinds of stuff like that. And then the next thing is mixed or interwoven client server code. And basically the idea there is you want to be able to write the code as a client function that happens to also call out to capabilities on the JVM. And running mixed code is inherently asynchronous. Well, you're going to send a message. So you got decline here, you're going to send a message over here to the server. And after it does whatever it does, it sends back a message saying, here are the results. So this technique, though, with mixed code in Saite is done in such a way that the intermixed execution appears to be synchronous. So if you're going along and you hit a thing that's supposed to run on the JVM in your code, it will look as if it stops and waits for the JVM to do its thing in a completely synchronous fashion, and then only after that's finished will it move on. And that's implemented by rewriting the code into promise chains. We talked about this last time too. This is mostly enabled because the editor is involved in all of this stuff, like this editor here, or the primary editor for this document tab, which is, we can open it up, it's over here. All these editors are directly programmable in ClojureScript. And so you have the ability to take entire forms or groups of forms, interrogate them in various ways, and then turn them into Clojure data structures, and then manipulate them however you want in terms of rewriting the code. So there's 2 indication modes for this at the bottom of any of these sorts of intermixed codes. The base level thing is the special CLJ tag. And we'll see some of that over here when we start exploring this in live example. But this tag is not a macro, but some people, when they first see it, they think it's a macro, but it can't be because it reaches out to the outer form and rewrites everything. So this tag is just a tag. It doesn't actually mean anything. Doesn't have a value associated with it or anything. It's just a tag, a symbol that's a tag in the code for the underlying editor function to realize that there's a CLJ form within the enclosing forms, and that the outer forms all need to be rewritten into these promise chains in order to make this look like a synchronous execution. Second thing is if you define functions on the client that have a CLJ or a mixed mode function in them, those functions will have their metadata changed so that there is a metadata of CLJ true on them. And we'll see that as well. And the reason for that is because if you use those functions, even if you don't inside of other client code, even if you don't see any CLJ tags in that client code, those things will be rewritten as well, because they know that, oh, that is a mixed mode function that basically is making calls out to the JVM. And that kind of thing happens in a recursive way. All right, so let's just look at some of this. We'll fool around with this here. So let me slightly change that. Okay. So here we did a little bit of this in the first session. We're going to do a quick review of this. We'll run this on the JavaScript side and on the JVM side. So if I come over here, put the cursor at the end and do Control-X, Control-E, there you go. Nothing surprising, nothing particularly interesting. But code just runs. And then I can do a Control-XJ over here and you get the same thing. The only difference is this second one was run on the JVM. There's almost no difference because the JVM enclosure defaults to doubles for any kind of floating operation. And in JavaScript, all you have are doubles. That's your numeric tower is just doubles. There isn't anything else. So those results look pretty much the same. So we click this thing over here, our callback calls and clears the buffer. So let's define a couple of resources that we're going to use as we go along. Actually, we're going to use them in the final dashboard example even. So what this is it's a URL that contains a annual mean temperature database that actually Kira McLean showed in a really nice talk on visualizing things with Hanami, and actually have, let me clear out a couple of things here because I want to show that. Yes, so here it is, and I can scoop this up and put it in the chat for people who want to take a look at this. She uses this data set that we're going to look at in this talk, but it goes into detail about templates and transformations and all kinds of really cool stuff that you kind of need to know something about in order to actually understand how all this really kind of works at the end of the day. So it's a very nice talk. Okay, so let's get back to, actually, wait a minute, there was a, chat message in there. Does this mean if a form that should be thrown out to the JVM but doesn't have CLG, it will still run asynchronous and will still reach out to the JVM or just throw it there? So let's go back to our stuff. Maybe we can talk about that in a little more detail here. Okay, so what happens is if you're running these things and I do a Control-X, Control-E here, that's nil because when JavaScript doesn't know what anything is, it just returns undefined, and undefined is nil in closure script. But if I do a Control-XJ here, then I get the full, I get this thing. So when we're running interactively, we don't need to have a CLJ if we're just running on the JVM. So in this case here, so I'm running just on the JVM, so I can just say run it on the JVM, and it returns my result here, which is a kind of a jumbo URL. I guess I should have made this output buffer bigger, but yeah, anyways. Same thing here for like this TC data set. Oh, this is worth noting too. Let me just do a slight aside. We already pulled in our depths, so we can just execute that on the JVM. This has already been done, so it'll be very quick. But yeah, normally this runs. So we do our depths and requires of all the stuff that we're going to want to use on the JVM in this thing. So that's where this TC comes from, because that's one of the things that was required, which is tablecloth, which is a wonderful library by Tomas that layers on top of Chris's wonderful library for data sets, like data frames in R, Python. So we're going to use that in order to read these data sets in and transform and whatnot. So if we just take a quick look, we can do these in steps here. So if I now execute this on the JVM, I get this result table. Here's all the columns in there. And so we're not going to use everything there. So we'll do these in pieces. We can rename the columns. There's a way to tell it to rename everything as keywords, but that works only if you don't have spaces and stuff in these things. Otherwise, the keywords get all confused. But we can do them kind of manually for the ones we care about. And then we're only going to grab those. We just select those columns, only those columns. So if we run that, that's what we have now. So now the only thing is this year is an integer, and Vega Lite doesn't understand dates as integers, unless they're like microseconds or something past some epoch or whatever. But when they're given like this, you need to turn them into strings so it will understand what they are. So we need to do that. So all we have here is the year, the geographic region, and the annual mean temperature for that region for that year. So we'll convert those things to strings. And in this case, we'll just pull out the region that's the UK. So there you go. So that's running all that on the JVM. That's great. But now let's run on JavaScript in the JVM, and it's synchronized by rewriting to promise change. So here's that CLJ tag. So everything in there, so I'll just let all this stuff down into here, is going to run on the JVM. And when it finishes, then on the client, we'll bind the result of this thing, which is calls and rows, to the client's calls and rows. So this is client code here. This is JVM code. And then at the end of the day, what we'll do is we'll zip map them. And this gives us that, oops, did the wrong thing. And this gives us the data in a form that Vega Light will be able to understand. So Vega Light wants a vector of maps. There we go. The reason why, and this is actually an idiom that I use a lot. In this particular case, it doesn't mean that much because there's not that many rows. There's not that much data in the data set. Oh, wait a minute, there's another chat thing here. Oh, okay, okay, right, okay. But if there's a bunch of data, it's actually much more, I mean, we could have put this map inside of the CLJ form, right? We could have just as easily done it there. The problem is that when you send the maps back across the wire, that's way more expensive than sending a vector of vectors, which is what the rows are. And the columns is just a single vector of just the column names in the order in which they're defined in the data set. And then by doing that, it's much quicker to send that back and then zip it on the client than it is to zip it on the server and send the complete result back to the client. So that's kind of an idiom that I use a fair amount. Okay, so that's great, but instead of just writing these top-level forms all the time, it'd be good. Maybe we should capture that in a function. So we'll define a client-side function for getting the region and annual mean temperature data. And we'll do it so that it runs this stuff on the JVM and then zips it as in the returned part. So if we execute that, one of the things we see here is we get this meta FN. And the reason for that is that it's been tagged with that metadata for the fact that it knows that this thing was a function that has JVM code requests in it. And we can actually look at that. Again, how this happened is all gone over in the first session. But here's the promising that where this thing gets rewritten. And in particular, at the very end, that symbol is rebound to the original function, which was defined here with all of this stuff, but with the metadata set for of CLJ true. And that's how the machinery then can interrogate any given symbol to see if it's one of these functions that has JVM requests either in it directly or indirectly. Okay, so now we can just call this thing. We can just call this function now over on the client side. Oops, what did I do? Oh, there we go. The one thing we got to remember though, you can literally just use Control-X, Control-E here because now this thing is just a JavaScript function that happens to know that has to wait internally. And since we're not doing anything else with it, that waiting works. But that's not good enough if you're going to use this inside of a function. So that function, if you use this thing inside of another function, then you have to remember to compile that function as a mixed mode thing. Otherwise, what will happen is that the JavaScript code will run so fast that the value will be a promise. And so your code will be like, I don't understand what to do with a promise. I'm expecting a vector of maps or whatever it is. All right, so now let's actually just paint this thing. So we're going to actually take that data and just display it. And so we're saying the X field is, and we have we're going to use a point chart because it's kind of a scatter plot. And again, this was gone over in the first session, some of the magic here about how this works. And so here's our data. And here's the year now comes out the way it's expected because we told it's temporal and we converted the year to actual string so it knows enough to figure that out. And there you go. And that's just for the UK, but here we are and we plotted it. So that's a way in which we're using this mixed mode capability in order to paint a visualization that requires data to do it. Now, in this particular case, you can say there's not enough here to make a real difference, but there are times when, certainly in some of the data sets I use in the labs, where there can literally be hundreds of millions of rows, and trying to do anything like that on the client is just a non-starter. So you kind of need this mixed mode capability. All right, let's go on now. So let's talk a bit about widgets. And widgets are a kind of glorified component. So it's just what it is the component level version of abstraction using templates, economy templates, as in this talk here. But for defining higher level widgets. And the thing is yes, so it's based on the Recom components. Any Recom component can be used. The typical things in your dashboards are things like sliders, buttons, checkboxes, selection lists, drop downs, all that kind of typical stuff. But you can also use layout components, you know, horizontal boxes, splitters, scrollers, all kinds of stuff. So just like this is a splitter, you can have that actually as part of inside one of your dashboard definitions. And again, because it does this flex layout, everything kind of magically fits where it's supposed to and magically behaves kind of the way it's supposed to. Yeah, so that can be very, very potent if you use these things. So what you do is you use templates, which are this nifty recursive rewriting technique. It's a subsystem of economy. And again, this is a great intro for understanding what that stuff is. And we use the same technology, that same rewriting capability, in order to abstract over the top of these Recom components, so that you end up with much simplified widgets. And these widgets may even be composed of multiple components that you kind of turn them into one thing, that which are then parameterizable. And at that point, you can use them as very high level constructs. You just use these things. You don't have to think about them too much anymore. And the transformation of these templates, just like the transformation of templates to define visualizations for Vega and Vega Lite, the widgets in the picture frames are transformed along with VisSpec. And you say, well, okay, what's a picture frame? Again, that was gone over in the first session, but it's a Hanami concept, really. And everything in a body over here, like this entire thing we're looking at here, is actually a single picture frame, as it turns out. Its picture frame has a top, right, bottom, left panel element with a visualization in the middle, and the visualization can be empty. And actually, most of these panels can be empty. You have to have at least one of these things, otherwise you don't have anything. But you could just have top without a right, bottom, left, or a visualization. And in fact, that's exactly what this particular thing is. It's just a top that happens to use a splitter, and the first panel is this markdown stuff with some pictures, and the second panel over on this right hand side is an editor. And an output area. Now these editors always have their output buffer someplace, and they're always on a splitter as well. So that just happens magically. But the key thing is inside one of these panels, you can have an entire set of stuff, an entire dashboard laid out on the top or maybe on the left-hand side, and an associated visualization that's reacting to things as you fool around with them. Yeah, and so all 4 of these panels can have basically any sets of these abstracted or explicit Recom components if you're just writing them and you don't want to try and abstract over them. So let's take a look at a little bit of this. So now this thing is already defined. And let's take a quick look at that. That's over here in this widgets thing. So there's a bunch of pre-canned widgets that are already set up that can be used. And so slider input is one of them. So if we're over here in widget land, slider input. So this thing is actually already defined, but this is how it was defined. It's just a vector of, this is a Recom component, this is a Recom component, this is a Recom component, and so is this, and then we have the actual slider. So what this basically is saying is that we're going to create a flex box that's a vertical in terms of its component layout. The first component is a label. The next component is a horizontal box. And inside that horizontal box, we have a label, another label, right? Then a slider, and then another label. Okay. And the reason why I have these labels is it's kind of nice, because then these labels will end up being the min value and max value of the slider, and they'll be on each side of the slider, to the left and to the right. And so, yeah, if you look at this, it's just, we can execute that. And it's just, yeah, it's just, since it's a quoted thing, it's just, there it is, just nothing but that. But we can transform it now. And in this particular case, what we're going to do is, a lot of these things have some defaults and stuff, and they'll get translated during the transformation. But we're going to change this label here to a title, and then we're going to give the model as a ratum called test with 1. And then the final thing is a symbol, which has to be, if this was real and live and useful, it would have to be attached to a function in that symbol database, in this symbols database thing over here. But in this case, all we're doing is just taking a look at what the result of this stuff is. And you can sort of see, okay, so now we have our label high. And so when this is all displayed, it'll look kind of like what you would expect. It'll be a high on top of a slider with a label on the left and the label on the right, with the minimum of 0 and the maximum of 10. And then the slider also has a step of only 1 in this, and it's 200 wide. I mean, some of these things have defaults, and you can just change them however you want. And then on change is this test, which right now doesn't really have any function associated with. So if you try to actually run one of these things, it would cry out and say, I don't have any definition. All right, so let's go further with this. And in this case, I have to, I got some magic code over here that I haven't put into this box because I didn't want people to sort of be running ahead of ourselves here. So I just got it in another buffer. I'm going to do some copy and pasting. So first we'll have a basic callback. Doesn't do much of anything except print to the JavaScript console. And then we'll grab some other definitions. Let's put these over here. Okay, let's make this back to where we were. So all this is going to do is write. When that callback function gets called, it's just going to write to the JavaScript console. And we need to add that our slider FN test. We need to add that to our database. And in this symbol database, this function symbol database thing is in a way what it does is it effectively implements bars in this context. I mean, I don't want to say it does it in a kind of completely general way for all of any ClojureScript, but it certainly works in that fashion for what it's doing here. And the reason is because ClojureScript doesn't have vars. There isn't that indirection. There isn't that nice indirection thing where you have a var and then the thing in the var, and you can always refer to the var and then change the stuff in the var. Magically, it will always be updated and start working with the new stuff that you put in there. So what we're doing effectively is kind of creating a var database. Then we got to put our Recom in. And now, well, let's paint this thing. Let's see what this looks like. So there we go. This doesn't have that funny, when we do this, it doesn't realize that there's another frame in here because this editor doesn't have the frame of the actual, this whole thing is a picture frame. And then this thing is a picture frame. And since we didn't tell it that there's a picture frame already in this buffer, it just thinks, well, I'm the first one. So it paints it on the top here. Anyways, so here we are. It starts out with a 1. But if we click this, it doesn't look like anything is happening because we didn't have it do anything except write to the JavaScript console. And we come over here, you'll see that, yes, it's definitely doing that. It's writing the stuff out. I mean, let me make that maybe a little more explicit here. We'll just push this up. And now we'll click around on this. You'll see that it's popping that into that console down there. And that's like, okay, that's great, but it's not particularly useful. So let's get rid of that. And now let's grab, well, actually, let's just, let's see if we can just type this in without breaking everything. All right, so what we want to do is we want to make sure that we update the Recom when this thing is called with the new value that gets passed to it. Okay, so let's take this and get Recom, and we pass it in the name, the ID for this thing. And come over here, pull that inside the let. So we'll still type to the console, but let's do something that'll show that there's some reaction going on here. Let's reset that Recom to V. Right, now we'll execute this. And let me do this again. So we have that, but what we have to do is since this is actually, the value of slider FN is the actual function object. So we just created a new one. So we have to tell it to re-register that thing properly. And we can let's make sure this Recom starts out at 1. Now let's paint this thing again. All right, now we come over here. It's still typing to the JavaScript console, but now at least our model is updated and the slider bar does the right thing. That's great. Oh, we also have slider test. That's our label. Where is our label? Yeah, right here. So that's how that gets put up there, which we saw in here. With this piece, oops, with that thing. All right, so that's great, but it still isn't really what we're after. What we really want is for this slider to control the data that's displayed. So let's have another update to our function. This time I'm just going to copy and paste it so that I don't bungle something here. Come on over here. All right, so let's just so that we don't get confused, let's get rid of this thing. All right, so now we're going to add data and update via this slider. So what we're doing, we're still doing the, I guess I could just use reset here. We're still doing the update to the Recom. We're still printing the thing out. We actually print the slider data to the JavaScript console. Probably I was doing that for some debug reason. I don't really need to do that, I guess. And then what we're going to do is visualize the new data points. That's it. And this is just JavaScript interop. We're grabbing the HTML. Down here we have this bid ID. That's how it knows that. And when these things are painted, this VID gets attached as the element ID of the containing HTML div. So then that's how this thing is always able, you can grab that element and then visualize is telling Vega to paint the thing in this div or to update the viz in that div. So let's execute this. All right, and we got to do this again here. And let's just make sure we start with 1 for the sake of argument. All right, now we're going to paint this thing again. And now we should have our picture updating. And so there you go. So now we have a widget that's controlling our picture. So that's the beginning of a kind of like a real dashboard. All right, so we're getting close to where we'll build a kind of more interesting version of this thing. Let's get rid of that. But first, let's do a quick review of the API for what, and we've already seen some of these things. We've already run some of them. There is this ability to programmatically update a frame instead of doing the Control-X, Control-I to paint it in there like I was doing. And same thing with deleting the frame. You can do it programmatically. There's these callbacks to add and get Redoms. We've already seen that. And the same thing with add symbol and get. We haven't seen this, but that's kind of implicit. Then there's the visualization, which is just a thing directly from Hanami. Right here. Sort of tells you what it does and how it works. And just as mentioned in the previous session, all these things are automatically required into any namespace that you have in Saite. So anytime you create a tab, you have the ability to specify a namespace. So just like this tab, this one here, the namespace is Saite2.code. And all these SE, all these Saite core functions and Hanami functions and other things are automatically required into this stuff. So you can just use it without having to remember how to require everything and what the heck you're doing. So it's all pretty straightforward and standard stuff. This one here is a little more interesting, and it only really comes around as an important thing if you have a callback, a set of callbacks, or a callback that has a whole set of things that you need to run in order, and they're all have a variety of asynchronous stuff going on, and you want to ensure that they all run one after the other, but only as each finishes. And so this is a helper function that works kind of nice. So you can pass in a vector these promises, and kind of runs through these things until it gets to the end and it says, well, there's no more promises left. And then it does this body function, which is kind of the finishing thing. And sometimes if you have a long, complicated chain of stuff that you want to ensure that has a lot of asynchronously in it, and you want to ensure it all runs synchronously, you can use this thing to do it. And it'll always make sure that it builds a promise, wrapping everything in the right order and all that kind of stuff. So that's kind of cool. All right, so let's get on to kind of the main event of this thing. Okay. This is worth talking about for a couple of seconds too, I guess. So let's add one of these things. We could put Saite 2 here, but we don't even need to. It's just, we can just do this. That's if you don't specify anything, that's the default, this doc.code thing. And you can, if you did that, we could edit, you can edit this, you can change it to Saite 2 or whatever. And then you'll have that, then everything in this tab, the editors will be running inside of that namespace. Actually, this was sort of a dumb thing to have done, I guess, because this isn't the kind of, this isn't the, oh, okay, I tell you what, let's just add what we really wanted, what I really wanted to add one of these. These different tabs, described these in the previous session of how this all is, but this is the one where you have just your regular editor and output stuff. And what I want to show here, we sort of went over this in the previous session too. There's different code and all this stuff is shipped with it in the self-installing WidgetArt. It's also directly available as URLs. So if one of them is updated beyond what your most current thing is, you can just pick up the URL. But most of the stuff is readily in here. I mean, that's how we got our TMD thing. Like if you go and you look, you can get the you know, all this stuff. So you can just automatically grab the right versions and all that kind of thing. And there's other ones in here. There's a lot of this canned stuff, so you can just quickly do things without having to remember or think about it. So you can pull in Neanderthal, which is really, really handy for a variety of things. You can do stuff on it. But in particular, right now with this one, what I wanted to show is we have these templates. And so there's pre-canned templates. One is like the widgets, which is literally the same, is literally the widgets. So if you pull that in, this is how this buffer over here got defined. They just went there and pulled it in. But the other thing that we have is we sort of have started a machine learning charting library of templates. And that's where we got, well, so this also has this residual rule and some other stuff. And then, but that's also where we have this trend chart. And again, Kira actually goes into that particular template and how it got constructed, and you know how you can then use it as an abstracted thing and all of that in this video. So yeah, she does a really good job. So I highly recommend that. Anyway, so that's where this stuff came from. Let me get rid of that, I guess. Don't really need that. Don't really need this. Get rid of that stuff. Okay, so here's where we want to be. So here's our trend chart. And it's parameterized by these data X, for the X-axis data, data Y, for the Y-axis data. Maybe these names were a little overdone when we did it, but you can just make them anything you want. We happen to choose those. It has an X type and a Y type, defaulting to the standard capital X type and Y type stuff. And in particular, it has this thing too. It has this lowest bandwidth. And this lowest bandwidth determines the data window size for the smoothing function. And people who are familiar with lowest know exactly what this is all about. But basically, what it is it's a percentage of the total amount of data around any given point. So it defines the local neighborhood size on which you're going to build this function fitting, if you will. And most of the time, they're no more than like a second-degree polynomial. So you try to do a second-degree polynomial fit to the data at the closest way. And that's basically what we're going to be interested in fooling around with. And it's got some other stuff in here, whatever. But now we can also, so let's just try the base trend chart. So we still have our GSS region annual mean temperature thing defined. So let's, so we run that. We get all that stuff down here. So we have this data. Okay, so we can paint this. Let's just paint this thing. And there you go. And this looks very much, this is basically exactly the same visualization that Kira ends up with in her stuff. Now, what we can do is we can sort of do some exploring and say, well, what about that trend line? Well, we change the window here. We can sort of change it. So if we got a much bigger window, you can see this starts to become much smoother. And in the limit, it'll effectively become just a line, just a simple regression line. So if you pour this out, get closer and closer to just kind of a straight line with a small inflection point at the midpoint. But we can keep doing this, just by hand. But maybe that's not something that's particularly interesting. So you say, well, you just, especially if it was much more complicated, you'd be like, well, I don't want to have to do that by just fooling around with this code. So let's actually define a slider. And let's come over here again. And here what we've done is we said, well, we're going to take this trend chart and we're going to create a new chart where we put some of those picture frame elements. And we're going to have a top with a component of markdown. And then we're going to have the left is a sidebar that has two components, slider input, text input. And these are just coming directly from over here. So here's our sidebar. This is how it lays components out using this flexbox thing. Here's our top. It's the same kind of thing here. Here's our slider input, text input. So listen, and there's the markdown. So what we're gonna do that. So we just have a top frame with just this markdown for the title, and then a slider and a text input. And then we're gonna say also that we're gonna directly tie the text input model and callback function to the sliders model and callback function. So they're literally going to be the same thing, so that they'll work in concert. So this should already be defined, but we can just define it. And then we come over here and we'll start kind of like we did before. With a very simple thing that just updates the slider. And we'll add this thing, just like we did into the two databases, the Recom and the symbol translation stuff. And then down here, we have our model, which is the Recom that we just defined. And our callback symbol is this, which is connected to this guy. So if we paint this thing, we'll now get, there we go. So there's our nice title. Then here's our left bar over here. And if we click this, you'll see that the text box is updated. And if you came here and you put in a 9, that works because these two guys are tied together. But it's not doing anything with this. So we need to add more stuff to that. And let me go and grab this stuff. So let's kind of cut to the chase on one of these, on this. Come over here. Get rid of this. It's not what we want anyways. All right, so now we have a fully functioning slider with the lowest capability, or at least this is the theory. So actually, let's just delete this, get rid of that one. And we have to define this again. And then the same thing, let's just start the Recom at 0.3. That's actually the Vega like default 0.3 for the window ratio. So I'll just start with that. And then we can paint this, but let's look at this a little bit. So what we're doing now is we get this value, which is just going to be a number from 0.1 to 0.9 in steps of 0.1. And what we do is, we're going to now run on the UK, get the data set. So this is not as efficient as you would in a real thing. You'd probably want to cache this, with memoization or something else. You don't want to recompute this every time you click this slider bar. That doesn't make any sense. You're just getting the same data. You just want to rerun the lowest function on it. But for this demo, this is straightforward enough. And what we're going to do is pass the value that we have as the new lowest value, and then just repaint the thing. Okay, as you can see, it's now doing what it's supposed to be doing. And so we're controlling this without having to type it in by hand each time. We're just letting this slider do the work for us. So yeah, it just goes and grabs this UK data, swaps out the value into the Recom for the slider, which automatically updates the input box as well because it has the same model. And then we visualize this, where we specify the lowest bandwidth as the input value coming from the slider. So okay, so let me, as long as we've gone that far, let me try one other thing. So this is, let's just actually let me delete this. And let me just kind of all right, so what we're going to do is let's get rid of this thing.
So quick question.
Yep.
So you have the right angle bracket on data X and data Y.
Oh, right. That's just
that's a naming convention, or
it's just a convention. Yeah, I mean,
what does it indicate?
like down here, for example. Yeah,
Yeah,
all it means is that this should be swapped for with the year, and X type is temporal. We can take a quick look at that. Let me just paint a couple of things here first. Because what I'm going to do, what I'm going to attempt to do, is add a region drop down to this stuff. But okay, let's take a quick look at this thing first. If we look at this, if we transform this thing, so this really all is all about, again, the Hanami template rewrite, recursive rewriting stuff. So if we don't have any data, we'll just do this. And what we'll see, if you remember, if we go over here in the, we have that the data for this thing is this data X and data Y. And so those things will get swapped into the values for that. So in other words, anything that you give for data X will become the X value, and for data Y, that'll become the Y value in the Vega Lite encoding. So if we go over here and look at this output and just find the encoding part, that's all of our picture frame stuff. Yeah, down here. You'll see now that the field for Y is the AMT, which we gave here. So the AMT becomes the Y encoding. So here's the whole Y encoding thing. The field is AMT. And the same thing with X. Its field is year, as given by this, and its type is temporal. It's given by that up there as well. So that's all part of that recursive transformation for Hanami templates. That's what's going on there. We could have used anything. You could use anything for these substitution keys. There was a discussion about one possibility of having something that may be a little bit more informative, where you have this arrow meaning, oh, I'm replaced by the thing to my right. I'm to be replaced by the thing to my right. It was kind of a convention that maybe was some people were thinking might be slightly more informative than using the capital letter stuff. You know, everything here is all done with this capital letter stuff. Same thing here with the min, max, and whatnot. Okay, so let's finish this up really quickly here with the hope that it will do what I want. Okay, so I got to make sure I'm in the right place. So that's the slider. Okay, now we need this thing. I'm just cutting and pasting this stuff in here. Okay. And then I need some more database update stuff, and then a new form for the description of the spec. So let me paste this in here. All right, let's get rid of this one. All right, then it's quickly, what we have to do is we need to also, so what I'm going to do, the idea is to add a drop down to this definition of the annual mean temperature chart. And we already got the choices laid out the way we need, because this is already run. This format is typical, is a Recom thing. It's for drop downs, kind of wants this kind of a layout. And then we have to now add a drop down. So we have our slider, our text, and then we have a gap, and then the single drop down component. So if we define this now to be our new version of this chart, and let's execute these things. Let's add this in. Set this one for the region. All right, well, with any luck, this will work. Okay, so there we are. Now let's see if this works. Yay. And in theory, we can select a. There you go. I'll go to Wales. So the key thing with this is we just have to ensure that we have our ducks in a row. So we need to, for the slider needs to know what the region is. So it goes and grabs the region. And then it has to have the label, because that's how this function knows what to do. So the region has to be the label value, not the thing passed in, which is actually the EID, which is just an integer. So we turn that into the actual label, which is going to be one of these values, just like with UK, which is the kind of the original thing. We just don't have UK hard coded anywhere anymore. And then all the rest of this stuff is the same. And the same thing down here. We just have to make sure we get the right region, generate the data, and then set the RADM stuff and then visualize. So there's Northern Ireland. We can fool around with this. Wow, that kind of looks different. Yeah, so there. So now you have, it's the beginning of, I mean, there's different things, there's other different things you can do with this. I guess with this, maybe there's not a whole lot more. You can maybe layer, you have different colors and have, instead of a drop down, a multi-selection box. So you could have both England and Scotland at the same time with different, you can turn this into a much more layered thing. But in general, I guess that's kind of the end of the story here. And so there's how you can create these dashboards. And you can have very sophisticated versions of this stuff too, as far as that goes. If anybody was at the last session, you saw a pretty sophisticated one for the lab that does all this reads, alignments, and annotation stuff for genome data sets. So it has a whole lot of stuff in here. But, and then, yeah, you can just close this up, get rid of that editor as far as that goes. And now I can just, now it's just a completely a visual thing. So that's it, except for any questions.
So are all HTML input types supported for interacting with these visualizations? I guess there's not that many more, but yeah, I guess you got text boxes, buttons, and radio buttons, and
you have any of these things are available. Any and all of these things, including stuff like this progress bar. You could even do the throbber stuff, I guess.
So anything in Recom you can
Anything in
use?
Recom. So these date pickers, input times. Here's our drop down. This is the same thing as what we just used. Here's a selection list thing. Here's a multi-selection list. I don't even know what tag drop down is, so I don't know. Well, it's alpha, so I guess I don't know what that is. You can literally have tabs. So you'd be a set of tabs within a tab within one of Saite's tabs. You could do type ahead stuff. You can do tables. You can do these tables. Admittedly, this is alpha, so who knows how robust that is right this minute, but you could popovers, any of this stuff.
Oh, cool.
You could have, yeah, alert boxes, depending on what you want to do. These things are really, really cool. Any of this kind of stuff where you add scrollers and things. Or splits. You know, there's all this is really cool. You know, for kind of organizing and laying out your geography, if you will. Yeah, so any of those things are usable, and obviously they're usable in combination. Yeah, so I mean, if you look at this, you open this thing up here, and we just, I mean, this is, let's just do the transformation without the data. You will see, because of the way we had defined all this. Okay, so here's our frame definition, which goes back to this picture here. So these panels, top, right, bottom, left, are the frame elements, and each of those elements can contain any combination of Recom kind of code widgets and stuff. So if we look at this, yeah, okay, so here's the frame, here's the top. So that's that top panel. This gap is a Recom thing. It's just a nice way to, there's other styling you could do with this gap. This V box is a flex vertical way of laying components out, and these are the children. It only has the one, which is a markdown. Okay, which we defined as our markdown widget over in this stuff. And then the left panel, there's a paragraph that sort of has a width to it. It kind of pushes this over. It kind of gives you a gap here to, or when it's closed, it gives you a gap to this left-hand side of your window. And then there's a V box within which we have the widgets we had defined. So we have a label, which is this lowest which is the sliders label. Then we have a horizontal box. So we'll lay out our components horizontally. There's a label, which is the 0.1. Then there's the slider definition. And then there's the right-hand label, which is the 0.9, as the kind of corresponding to the maximum. And actually the way the defaults are set up in the transformation, these that happens by default. And then, okay, so and then we have our input text. This is still part of this V box thing. We have input text, which is a model of point. Yes, this model, which is the same model. It's exactly the same model. That would be an identical if we did a comparison enclosure. And it's tied with the same function, same update function. And that gives us this, just this simple text box. And then we have a gap of 50. And then another VBox, which is just this. Select the region, it has a label, and then a single drop down. And these are the choices. It has the on change and all the rest of this. So there's a lot of stuff there. All those are Recom components, but we abstracted all of that stuff. So when we
Yeah, maybe go over
Yeah.
that again.
Yeah.
That is,
Yeah.
everything's, the interactivity is all driven by the on change event.
Yeah.
Then the function is called and an atom is updated. How is that whole propagation of
Yes.
the input
Okay.
events happen?
Yeah. So when I click this thing, that calls that on change function that's attached to it, which in this, which in here it's for the slider. So we have to go down and actually find. So this is kind of a nice example of the abstraction of templates, though. I mean, when we define this, none of this more complicated stuff was specified because it was bundled up in the definition of the actual slider widget. But yeah, this thing here on change, that's what gets called. And that's our on change function up here. So when I click that, that function runs. And when it runs, it goes and grabs the region to make sure it's going to work with the proper data set, because the way we did this here, like I said before, you'd probably want to cache this or something if you had real data sets. But the way it does now, it runs against the region that is selected, and then it updates the lowest and then visualizes. And the other thing it does is it changes the ratum so that the slider bar moves to the right place. And since that same model is for the text box, it updates the text box. So all of that happens when I click this. That function runs. Those 4 or 5 things happen over here, such that the model is updated, the slider bar moves, the text box updates properly, and then the trend line is recomputed and visualized. And when I click this thing, a similar set happens. So I have to come down here. Here's our single drop down. Here's our choices. Here's our on change. So when I click here and select something, Scotland, this function runs. And it gets past the ID. And if you remember the ID we had over here, see here. Yeah, it's this. This is a Recom thing. It just expects that your choices have a label and an ID. And the ID is the thing that's actually passed to the update function. I mean, we can just take a quick look at that over here as far as that goes. Here's the choices. Here's the model. Here's the on change. Pass the ID of new choice. You can actually have different ID functions, label functions, but the default is expecting that everything is encoded as a map, and then you just use these keywords, which is exactly what we have over here. And what's passed in when you make a selection is the ID of the selection. That's why you have to translate this into the label, because our GSS region annual mean temperature function takes the label, takes that string value, because that's what our code is, right? I mean, that's how that works. I mean, we've already seen that, like over in the mixed code thing or whatever. Yeah, if you want to see that really quick, yeah, it's just this. Point is this thing is taking this right here. It's taking UK. It's taking one of those data sub data sets in this stuff. So Yeah, so there's all this UK stuff, but there's all the other ones in there as far as that goes. All of those other ones being England, Northern Ireland, Scotland, and Wales. So we just have to translate to the label because that's what the data set stuff is expecting. And then we run our function to generate the data, our Vegalite data, and grab the ratum for this thing so that we can update it. And then we just visualize with the new data set. So that's what happens with this one. And then with this one, we do a little bit more actually. But again, in general, you probably, if you had real data sets, you'd probably want to be caching those things or something. Yeah, but this stuff is so small, it doesn't really make too much of a difference.
By caching, do you mean on the client?
Yeah, actually, caching on the client would make the most sense for something like that. If the data is too big, then you couldn't do that. It wouldn't make any sense. Yeah,
So you learned that basic pattern of update and callback, and
yeah,
it applies more or less universally.
yes.
So maybe we should open it up to the rest of the attendees. Do we have any questions out there for John? Maybe if people want to try to take this on their own, where would they go to start? With your GitHub site, or?
Well, yeah, that was sort of covered in the first one as well. Actually,
Should people go to the Recom pages and
you can
learn
go
those
there,
patterns?
Yeah, yeah, that's a good place to sort of understand how all this reactive component stuff is.
I guess reframe and then Recom.
I don't use reframe. So reframe is not used in this. It's on top of reagent directly, and then Recom is on top of reagent. I don't believe it's on top of reframe either.
Oh, okay, I didn't realize that.
Yeah, so reframe is more of a framework, whereas reagent and Recom are libraries that you could. Well, reagent is the underlying library for both Recom and reframe, as far as that goes. Right, but you could use Recom in reframe because it's a reagent based thing as well. But I don't use reframe in this. I actually don't do that. So it's all layered on reagent directly.
Interesting. I didn't know that you didn't need reframe at all, because I have done Recom widgets on top of reframe, but never directly on
Yeah,
reagent. Okay, good to know.
yeah. Recom itself doesn't require reframe. It does have the reagent stuff for sure, but yeah.
Got it.
Yeah. Yeah, so I would agree. I mean, if you want to know what all these widgets that are available, this is the place to go. If you want to understand a bit more about the way these things work, I mean, like the hiccup processing, you can go over here. There, and the reagent documentation is actually pretty good. I mean, there's a lot of it, and it sort of tells you pretty much a lot of what's going on. And it discusses all this stuff about these different flavors of functions. In general, if you're using Saite, you don't have to know much of any of this, to be honest with you. You can sort of get by with only a basic understanding. Because most of it is all kind of under the covers. You work at this higher level kind of stuff. The trick
So
is,
somebody, sorry, I was just gonna ask if somebody wanted to reproduce your dashboard demo. Is the code out there for them to walk through and kind of build it up piece by piece like you did?
yes, I think what I want to do, I'll publish this as well. I'll publish this actual document. So it'll be
Oh,
out
great.
there on the Arrow Saite site, along with the original Saite Intro 1. So all of that'll be there. So everything in here will be there. The bit that I need to sort of add, I suppose, is all the stuff that was in here, in which I was copying and pasting in order to, what I might just do is just copy and paste the entire thing into this body and save it, and add some comments about, you know, step by step.
Make
So-
sure you keep the mixed mode comment.
Yeah, exactly. But yeah, like this stuff is in there, so you can just walk through this stuff as far as that goes, and execute things just like we did. The widget one is the one I need to probably just copy and paste all the stuff into and save it. This is out there just like that. Then there's the dash code, all this stuff is there. And then the dashboard example. So actually that probably needs to be, we need to have maybe this all, yeah, maybe that's also true. So it would be another possibility. Actually, it might have made more sense now that I'm thinking about it. Would have been to have two of these tabs. Maybe I'll do that before I publish it. Is to have like two of these tabs. So like, is duplicate this thing. So this one would have this set up in it, and then this one would have the original one, which just had the single slider.
Yeah, good idea.
Yeah,
So maybe what we can do is we'll give you some time to get that squared away, and then we will publish the link on the meetup site,
yep,
so people will know when it's ready. And of course, we'll be putting the link to this recording up there as well, and in the usual places like Zulip and
yep.
Twitter, so Slack.
Yeah,
right.
yeah, that's great. Yeah.
Very good. Any other questions for John? General stuff? Microbiology?
Yeah, genome analysis.
Right.